We were looking at convergence to the steady state in the basic Solow model without technological progress and population growth. In the first part, we looked at the scenario where the economy was below the steady state. We want to do the same analysis, but now for an economy above the steady state. So we're looking at convergence to the steady state in our basic Solow model. So now the scenario is economy is above the steady state. Now we know in this basic Solow model, the steady state value of capital per worker occurs where investment per worker is equal to depreciation per worker. So this is the steady state value of capital per worker. And we know we can find the associated level of output per worker through a per worker production function y star. Now what we're doing is we're saying suppose economy starts at k naught less than starts at k naught above k star, right? So it's starting above the steady state. Say k naught is somewhere over here. So if k naught is somewhere over here, so let's take this to be k naught above k star. Let's just label this point as A. Let's label this point as B, and let's label this point as C. And we know from the per worker production function associated with k naught, output per worker is y naught. Now what we notice over here is at K naught, investment per worker, which in this case we can read from here is AB, right? This is investment per worker over here, right? This much is investment per worker, like I'm representing it to the small I over here. So this is investment per worker, which is AB. In this case, we can notice is less than depreciation, is less than depreciation per worker. And you can see from here that depreciation per worker is represented by AC. It's this entire distance that is right from point A to point C on the depreciation per worker line. Right, so basically if we want to read it, so this all is depreciation per worker, right? That goes from A to C. So then this means that change. So the idea is that so change in capital per worker, which is delta K, which is investment per worker. So that is investment per worker, which is AB is minus depreciation per worker is less than 0. Right, so delta K is less than 0. So we can see from here this represents delta K, in this case change in capital worker, the difference between investment per worker and depreciation per worker, which is less than 0. Since delta K is less than 0, this means that K is going to fall, capital K decreases from K naught until it reaches the steady state, until it reaches the steady state K star, where investment per worker is equal to depreciation per worker, right? Where investment per worker is equal to depreciation per worker, right? And graphically, we can show it like this. You're at K, right? You're at K naught. K is going to go down because change in capital per worker is less than 0. So as a result, it's going to go down until investment per worker is back equal to depreciation per worker at K star. So now let's see what happens to output per worker. So for analysis, looked at capital per worker. Now let's look at output per worker as well. Okay, so let's just erase this. So now what we're saying is, now we know since y is equal to fk, right? We know y is a function of k. So the idea is that we know this means that output moves with capital, right? Because it's a function of capital, positive function of capital, it moves with capital. So capital increases, output increases. So capital goes down, output goes down. Since y is equal to fk, so decrease in k. So when k decreases from k naught to k star, it results in decrease in y as well from y naught to y star. it's 2y star, it's steady state value, right? So this is a movement. So this represents a movement down the per worker production function. So k goes down from k naught to k star, y also goes down from y naught to y star, movement down the per worker production function. This is because obviously output is a positive function of k. It moves, output moves with capital. For production function, and you can show it over here as that when k is going from k naught to k star, y is going from y naught to y star on the per worker production function. So in this case, regardless of whether we start above the steady state or below the steady state, the economy will always converge to the steady state. So the conclusion here is, now if we clear all of this up, and the conclusion here is, if an economy starts away from the steady state, regardless of whether it's above it or below it, starts away from the steady state, it gradually moves towards it. Because if you're above the steady state, your change in capital per worker will be negative, so capital will go down until you reach the steady state. And as capital goes down, output goes down as well. And if you're below the steady state, then change in capital per worker is positive. So capital increases, and as capital increases, Y also increases until we're back at the steady state.